Did you get my email with the picture of the quiz?
I just did the Dropbox. I didn't see it in there. I have not done it.
Okay. All right. I sent it to you with email because it was 2 pages, and it's easier to send 2 pictures so you can read it.
Okay. All right. Yeah, we have a telecon every morning from 8 to whenever, and prepping for this class. So it's probably this afternoon before I get to emails. So. Mr. Andy, is there any way they've sent out some stuff that we're supposed to abide by for Zoom infiltrators, for lack of a better word? Can you use, there you go. Yeah, we're supposed to use a username. Thank you. So I think 2 classes have had some kind of Zoom infiltrators are problems, so they've got us instituting some things to try to not have that be a factor. We'll wait about 30 seconds more and get started. It's kind of a light day, so I don't feel as pressed for time. Any questions while we're waiting for a straggler or two? I guess I heard that trying to work on a graduation, maybe July 10th or 11th.
Yeah, I think
Mr. James, you probably have to head to West Point before that time, right?
I gotta go on the 12th, so it'll be kind of tight.
But when do you leave?
The 12th,
12th of June or July?
July,
Oh, so it would be graduate and go.
basically.
Well, yeah, I hope that happens. I would think the gym would be definitely ready by then, but they're talking about maybe doing it out on the football field if we need to have more spacing. They're putting in the roads and the parking lots by the gym today. Well, not today, but they have been over the last several days. They're putting the curbing and gravel, to look like they're prepping it for asphalting sometime in the not too distant future. All right, let's see, Mr. Daughtry, anybody know his whereabouts? Mr. McCaffrey, are you here? Did you sign in? You out there in La La Land? I thought I saw your name. No. Okay. McCaffrey, let's see, Tomlin and Walden. They've been kind of elusive. Anybody seen or heard of them? Nope. All right. Well, let me just kind of go over some announcements for you guys, and then just to kind of give you the game plan. We're going to do section 6.4 today. We're going to start it and end it all in one session. Okay. So, and it's I'm not going to get as deep in the weeds as maybe the textbook dictates we do. I want a couple takeaways from you that you understand, so that if you're taking stats next year in college or wherever, that it's not going to be all brand new. Mr. Or Mr. Toller, any way you can turn your video on to make
My computer's on really low battery, so it won't let me turn the camera on.
Okay. All right. Okay, well, let me just kind of go over some announcements. The quiz was due yesterday, and looking at Dropbox before it, see, Mr. Pillard, you said you sent yours in by email, and Mr. Hall, did you send yours in by email, or am I still waiting on you via Dropbox? And then just click the bottom left corner. You may be muted, Mr. Hall.
Do I gotta turn it in on Blackboard too?
I'm sorry.
Do I gotta turn it in on Blackboard too?
Did you do it by email?
Yes, sir.
Okay. I just looked at the Dropbox before class. I have the 77 students. The email,
Yeah.
doing emails has become a monstrous job, literally and figuratively. So,
Yeah, I won't do that anymore. But
okay. Well, but it's fine. We're all trying to just make this thing work as best we can with what we got. So I'm not going to get hung up on how you send it. Actually, Dropbox is kind of antiquated to access them, download them, and then print them. So a real efficient system. More efficient system to have you guys here. All right. So the 6-3 quiz was due yesterday. I think everybody that's online we're up to speed. Today we're going to do 6.4 Z notation, or Z of alpha. We're going to do that today. I loaded about an hour ago with the PowerPoint. It's in there for today if you have a way to access it. It's only about 10 slides, so we're gonna plug through them fairly quickly. Maybe even be done a little bit earlier. Okay. Then today's our last day, so I won't see you guys till after Easter break. Back after Easter, we're going to do the last 5, which is the normal approximation of the binomial. We'll do that the week after Easter. And what that is remember when we did the stuff, actually we did it with the 4-question, 3-answer quiz, and we had all that stuff where, we had like 4 trials, 2 successes. We had to do that, and then probably success. So it was what? 2 times 2 to the, or let's see, what was it? 2 to the 3rd power times 2 to the 2/3 power and all that stuff. Well, that's what this normal that was those binomial probabilities. And what we're going to do in 6.5 is take all this stuff and we're just going to put it under the standard normal curve and kind of show you how that works. There's a couple of conditions that have to be met to be able to take a binomial and put it under a standard normal curve. We'll talk about that. And it's a much quicker, expedited way of solving this using that standard normal curve versus all those calculations that we did, probably 4 or 5 weeks ago. So we'll do that the week after Easter, and that'll wrap up chapter 6. And then we'll tiptoe through chapter 7, which will probably, when we come back after Easter, what we'll have with seniors, I'll probably only have about 4 weeks with you. So chapter 7 will probably be it for seniors. So that's kind of the itinerary or game plan for today, and then for when we come back after Easter break. Any questions on that? Good. Okay. So what I'm going to do is I'm going to share my screen. Like I said, I dropped in Blackboard a attachment for the I think it's 10 slides for this section. If you have your textbook there, you can look in your textbook because the slides come out of the textbook. And I'm going to kind of walk you through it. And it's a little bit, to me, it's a little convoluted, but I'm going to just try to give you a couple of takeaways that I'd like for you to have from this, so that if you would see this next year in the stats class at West Point or Delaware or wherever, it's not all brand new. So let me do a couple things here. And pull up a thing here, and hopefully I can. That's really what I want. Give me a second. I'm still kind of learning my way around shared screens. So let me know if this works for you. Let me fill this out. Why is that not full? Put this down here. See if this does it. Okay. All right, does that say 6.4 notation on your screen?
Yeah.
All right, getting a hang of this Z-score stuff or this Zoom stuff. All right, so like I said, I'm gonna try to make this as painless as possible, and we'll walk through, it says only, I think it's 10 slides total, and actually the half of the 9th slide and the 10th slide is stuff I'm not gonna hold you accountable for. All right, so anyway, you're familiar with Z-score. Z-score, just a quick refresher, is how many standard deviations am I away from the mean? And if you remember the whole curve, under the area, the whole curve equates to probability of 1. And that curve builds from the left to the right, all right? And 99.8% of the data, if something's classified as standard or normal, is basically within 3.4, 3.5 standard deviations left and right of the mean, all right? So, since that thing builds from left to right, there are situations where we really want to kind of focus or hone in on what's to the right of that Z-score, and that's what this Z notation is. So it's read Z of alpha, where alpha represents the area to the right of the Z-score. So it's kind of a way to address the area to the right of the Z-score, and it's particularly useful or pertinent when we're talking about the little teeny corners. Let me see if I can, actually I can't do that because I'm sharing my screen. I'll show you in a minute, but it's talking about the little teeny corners at the very ends of the standard normal curve. And that's what we're going to kind of focus in on. And some of this should make sense because it kind of builds on what you already know. I'm not going to get quite as technical as maybe what the textbook would like us to do, but it's called Z notation or Z of alpha. And we're kind of focusing on what's to the right of that vertical Z-score or Z line. All right. Any questions or confusion before I move on? All right. So it says, I'm going to do some things on the board after I run through the slides, which will kind of reinforce all this verbiage that you see on the slide. So it says, so we're going to determine the Z-score of Z of alpha at 0.05 in the parentheses is the area to the right side of that Z-score, to the right side. Right? That's not a Z-score. And the reason, one way you can tell that is because the thing is within parentheses. Right? It's not a Z-score like how many standard deviations you are from the mean. In parentheses or Z notation is specifically talking about what is the area to the right side of that Z-score. Okay. Already mentioned that. The area under the standard normal curve is 1. I know we've got that down because we've talked about that forever and ever, with probability of P and Q and complementary events and all that stuff under the standard normal curve. So by subtracting a 0.05 from 1 gives us 0.95, and that would be the area to the left of the Z-score. Now we can relate it to something that you're fairly familiar with. There's a pretty good visual, all right? So Z of 0.05, and what they did is, and that's where it's a little bit confusing, is because Z-scores are always communicated into 2 decimal places or hundreds. So since they're giving it to us, where'd my little pen go? Since they're giving it to us in hundreds, let's see if this is right. Since they're giving it to us in hundreds here, you think it's a Z-score, but really it's this area here, but they abbreviated it to 2 decimal places, and that's why it's a little bit confusing, because we always talk about the area of the probability to 4 decimal places or tens of thousands, as opposed to 2 decimal places, which is what we've always used for Z-scores. So to kind of relate it to what was in that slide, if the whole area of the curve, if this area here, which is the shaded area, and I can't work this pen too well, is 0.05, you subtract that from 0.1, so the area to the left is 0.95. Right? So you can find out what this corresponding Z-score actually is for this Z notation or Z of alpha or Z of 0.05 by going to the table and kind of working from the inside out and finding a value that's either 0.9500 or closest to that. And if you did that, hold on one second, I got a latecomer. Let's see, let me let him in. All right, if you did that, okay, let me see, let me just look real closely. Get my table here. If you looked up 0.9500 on that table, it's kind of like right between 1.64 and 1.65. So that the z-score for this value would be I can do this right. It would actually be 1.65. Is that marker coming through on your screen? Writing? All right, even though it looks like third grade writing. All right, so does that make sense so far? So I'm trying to make this as painless as possible. I'm not going to get as deep into this as what the textbook does. So anytime, just to kind of clarify, because it's a subtle point and is easily misunderstood, is if z comes and the thing is in parentheses, like the z of 0.05, it's that value in that parentheses is the area to the right. Okay, so you're going to have to, as you can see here, do some math. You subtract that from 1, you get the 0.950, and then you look up and get the corresponding z-score of 1.65. Does that make sense? I've noticed all my classes, everybody's kind of gotten solemn, somber. It's not the excitement, enthusiasm we had a week or two ago. Everybody's kind of getting burned out on this way of life, including myself. Well, hopefully we're turning the curve. I'm ready to go back to other things. All right, so let me see if I can advance my slide. Okay, let me see if let's see if is that writing still on your screen?
Yeah.
All right, let's see. Guess I'm gonna, let me erase all that stuff. Sorry about that. So I'm still learning my way around. So this is just a little tiny excerpt from, I don't know if you can see me on the little tiny screen. That's the table we've been using all along, okay? This is kind of a little tiny excerpt from that, all right? And there's that, let's do this. There's that 0.9, there's that 0.95 value that we obtained by subtracting the 0.05 from 1. And here's the tenths of z-score. And so in this case, you had the 0.05, so it'd be 1.65 would be the z-score for that z notation, or a z of 0.05 in parentheses. Let me get another late straggler. Okay, let me get my roll real quick so I don't forget. All right. So like I said, this what you're looking at is just a real small excerpt of that bigger table. Any questions or confusion I can clear up before I move on? Good. All right. So let me see if I can advance the slide. It doesn't want to advance. Give me a second here, see if I can. There we go. And it just says that we use the z-score that corresponds there to the closest in value. So it's halfway in between those two, right? Exactly, that halfway. Yeah, it's right smack dab in the middle. Okay. Did I do that red line or somebody else? Right. So when the value happens to be exactly halfway between the table entries above, always use the larger z value. So round up. So if it's halfway in between, round up. And I'm not going to be a super stickler on that. If it's right in the middle, and you pick the smaller, the 1.64, I'm not going to, if there's any damage, it'll be minimal at most. But it says if it's halfway in between, always round up. Oops, let me see my little thing here is in the way. Let me just remove that out of the way. So in this case, it'd be 1.65. Questions? All right, let's see. There we go. So just a couple things to keep in mind that relate to this. And then we're going to do a couple examples on the board to try to reinforce what we've been talking about. So as the Z of alpha or Z notation is used regularly in connection with inferential situations, inferential statistics. All right, so that's your, if you think clear back to August, back in the good old days when we were in classroom here, you got descriptive and inferential. And inferential is your charts, tables, and graphs. And what are we talking about? Our charts, tables, and graphs, right? So it's used in inferential situations involving the area of a tail, no pun intended, extreme ends of a distribution curve, either the left side or the right side. And I'm going to do a couple of examples of both. The values of the Z will be used regularly come from one of the following situations. Z-score such that there is a specified area in one tail of the normal distribution, which is what we're going to do today, or the Z-scores that are bound a specified middle proportion. So if and what they're talking about, say, if we talk about the middle 80% of the population or whatever it is that we're analyzing, if you take the middle 80%, you got 10% on the left wing, you got 10% on the right wing. So that's what they're talking about. And being symmetrical, if I look, and I'll address this a little bit at the end if we have time, 10% on the left wing, 10% on the right wing, they're going to have the exact same Z-scores. They're just going, one's going to be a positive, one's going to be a negative. And I'll show you a visual that to kind of reinforce that. All right, example 16, which slide we looked at back, let's see if I can, yeah, that's example 16, okay? So that's what they're referring, well, let me look at it for a second. That's example 16 they're referring to. I showed a commonly used one-tail situation, which was Z notation, or Z of alpha, Z of 0.05 equals a Z-score of 1.65. Right? And it's located such that 0.05 of the area, it's really 0.0500, talk about it in 4 decimal places like the paper does, of the area under the normal distribution curve is in the tail to the right. Somebody's having fun with the colors. All right, that wasn't me. Because of the symmetrical nature of the normal distribution, Z of alpha and Z of 1 minus alpha, they are closely related. The only difference being that one is positive and the other is negative. And that's what I was talking about with that middle 80%. If I'm going to look at the middle 80% of whatever the data is I'm looking at, maybe the middle 80% of the SAT scores, I've got 10% on the left wing that's out of that 80%. I got 10% on the right wing that's out of that 80%. Where there's 2 vertical lines in that kind of trap that middle 80% are going to have the exact same numerical Z-score, except one's going to be positive, one's going to be negative. And I'll try to give you an example here, just when we go to the board. Any questions before I move on? It says in many situations, it'd be more convenient to refer to the area of the tail than to either the cumulative area or the area to the right. And that's what the purpose of this is. We're going to talk about those little teeny ends at either left or right, or possibly both consecutively. That's the purpose of this Z notation, Z of alpha. Right? Thus, we introduce an alternative algebraic name for the Z values found in a left side tail situation. We're going to do a couple of those on the board, which will, because by reading this, it's like, I don't have a clue what he's talking about. We're going to do it visually, which will clarify what they're saying here. And it says, for example, Z.95 and Z.05 have the exact same numerical value, only different signs. And that's due to the symmetry. Right? And we've related back to the 80% example. And that's where I'm going to stop. I'm not going to get into the stuff where it says in general or this next slide, because that's getting a little deeper in the weeds than what we went to. So I'm going to stop the share screen. Let me clean up my mess here. Okay. All right, let's see. I want speaker view. All right, let's see here. Let me, options. Okay. All right, any questions before I kind of give you some visuals to kind of reinforce the somewhat dry and boring slides we talked about? Any questions? All right, so let's, if you got a, let me see, let me get this lined up so we can, I want you to see what I, hope this will make sense. Okay. Let me get some colored pens here. Okay. Everybody here and see me okay? Good? All right, we're halfway through. Okay, so here's the standard normal curve, all right? The whole area underneath the curve equals 1. And we're going to talk about just this little winglet out here, right? So, you know, in the slides I just gave you, Z of C is that Z of alpha, all right, or Z notation. And for discussion purposes, so I'm not drawing 8 graphs. We're just going to depict this shaded area as C, and I'm going to keep changing the area that's shaded right there. All right, I'm just going to keep changing that way. I don't have to draw 6 graphs. I can work it all off of 1 graph, and we're going to talk about it individually. Make sense so far? All right. So, if for this case, just to kind of make things hopefully simpler, we're looking at Z of 0.10, all right? Which means this area in here is 0.100. I'm not going to write it up there, right? So if this area is 0.100, then we know this area is 0.900. Agree on that? So if we go to our handy dandy table, excuse me, and if you're using your textbook, it's Appendix 3 in your textbook, it's the exact same table, just formatted slightly differently, but it's the exact same values, okay? So if we go to 0.900, let me just go here. We know it's on the positive side because we're to the right of the standard deviation of 0. So we know all the z-scores here are positive. So we're going to start on that side, and we start looking through here. And we come up with, if you look down to 1, 2, and then come over to the right, that actually is Z of, the z-score for that is 1.28. 1.28. Does that make sense? If you've got the table and you want to kind of reinforce in your mind what I'm doing and where this is coming from, it's just look for the value closest to 0.900, right? So Z of 0.10, the actual z-score equals 1.28. So far, so good. I'm gonna do 4 or 5 more of these, but I don't want to move on until you kind of like, okay, I see what he's talking about. Make sense? Holler if it doesn't.
Doesn't.
I can't, you know, you guys are like little 1-inch squares. Someone's give me a thumbs up. Okay. So let's look at the next one. So we're going to change now this area here that's shaded is 0.0500, 0.0500. So if I subtract that from 1, I've got what? I've got 0.9500 here. So once again, I'm going to go to my table, and I'm going to look to the interior part of the table to find the closest z-score, right? So we know this thing's kind of pushing this way. It's going to the right, so we know it's going to be larger. And to find 0.9500 just real quickly, there's a, let's see, yeah. There's a 0.9495 and a 0.9505. I know I'm throwing a bunch of numbers at you. So again, it's right in the middle, like the example in the slides. So that corresponding z-score is 1.65. I'm coming a little closer. I don't need to be in the picture, but you can maybe see the writing a little better. The cameraman's got the shakes today. I think he drank too much coffee. All right, so that's that one. And if there's, ask a question. Otherwise, I'm just going to run down the line and we'll knock these out in rapid succession. So, so for z of, I didn't write it for this one. That was z of 0.05. And this was z of 0.025, or almost 3. All right, so if I subtract the 0.0250 from 1, that area makes this 0.9750. So you can see it's becoming repetitive. I go to my table, I look for 0.9750, and actually it hits it right on the money at 1.96. So that has a corresponding z-score of 1.96. You know what I want to make sure you understand? That parentheses, even though subtle, makes a big distinction. When that's z notation or z of alpha, so that's in that parentheses, or in that in that parentheses is the area to the right of the curve, and this is the actual z-score that corresponds with that. Z of 0.02. You know, stop me if you're lost in the sauce, and I'll go back over it. A 0.02 would allow, let's see, that would be, let me do my math here real quick, is 0.9800, all right? See a 0.02. And if I go to my table and look for 0.9800, the closest thing I can find is 0.9798, which is at 2.05, 2.05. Now, does everybody have their table with them by chance? I'll let you do the next one. Yes, no? Take a look at this next one. It's, excuse me, the area now in here is 0.0100. So if I subtract that from 1, I'll kind of get you started. I'm gonna let you do the rest. Let's see here. It's z of 0.01 is the actual notation. And the remaining space here is what? 0.9900? All right. If you got your table there handy, if you look that up, let's see here. It is, anybody see it on their table? It should be, if you're looking on your table, either in your textbook or the one that I gave you, should be 2.33 is the z-score for that z of alpha or that z notation. This is the correct formatting beneath it. This is the actual area, all right? The reason I did this is because it is confusing when you see 2 decimal places. You always think of that as being the z-score and 4 as the area. So we've kind of rounded the areas off to hundreds as opposed to tens of thousands. All right, one more to do on this one. So if I take the 0.0050 and I subtract it from 1, this area now becomes 0.9950. All right, so you know these, you can see the trend here, they're all getting bigger because this area is, this Z is actually moving to the right, even though I'm just using this kind of generic template to do all these. So you know the z-scores are getting bigger. This area is getting bigger. This area is getting smaller. That equates to 0.9950. And if we look at the table, closest corresponding z-score is 2.58.
Do we have a worksheet on this?
This is actually the worksheet. I was going to send it to you, but this is actually the worksheet. I can send, let's see. Problem is, well, I could do it as a PDF. because because I've had to color and shade things in. I'll send you a, I'm actually doing them all right now. So no, you don't have a worksheet. I'll be glad to, I can blank it out and let you do it on your own.
No, you're fine.
I mean, it's hard to do with this. This is a tough one to do. I was even debating whether just to skip this section because it's hard to do with this type of instruction and learning. So I'm just kind of walking you through it. So no worksheet. I actually want one. I can white everything out. I can send you a PDF of this and you refill it in. All right. Let's see here. Okay. Any questions before we move on? I'm going to do one similar series with just a slightly different depiction here. Let me see if it shows up. Give me a second because I'm looking. There we go. Bear with me. Okay, so now we're gonna move to the left side of the median. We're moving on the left side, so we know all these z-scores are going to actually be negative, right? We know all these are going to be negative. All right, we're just going to use this kind of as a generic template. And we're going to do 1, 2, 5 of these. So I'm going to keep the D is going to represent. I'm going to keep changing these areas here. All right. For D, all right, which once again, we're going to have to, since we're over on the right side, we're going to have to change these, all right? So, you know, the Z of alpha that we're doing really is Z of 0.995, all right? And if we subtract the 0.995 from 1, we end up with, let me quickly look, 0.0050. That's really what we need to then go to the table. And if we go to the table and find, we know it's going to be on the negative side, and we look for 0.0050, we get a negative 2.58. Now, if you look what's happening here, if you come over here, here's the positive 2.58. And this is what I was talking about, and I'll do a quick little drawing hopefully at the end. Because of the symmetry of these, all right, because of the symmetry of these, the z-scores are the same for many situations, particularly if we look at the middle 5 or 10 or 15 or whatever, 40%, 80% was the example I used earlier. The z-scores are going to be identical, but just opposite signs. Does that make sense so far? Mm-hmm. Mm-hmm. All right, so going to the next one. On the next one, we got 0.9900. That's this area here that's shaded, that's the D. We're actually doing, it's not a 2, so it's Z of notation of 0.99. We subtract that from 0, or correction from 1, we end up with 0.0100, all right? And if we go to our handy dandy table, we come up with a negative 2.33. Okay. Now I'm gonna kind of pick up the pace because I think I'm starting to become repetitive. So this next one is Z of 0.98. We subtract that from 0, or I don't know why I keep saying it. Subtract that from 1, we get 0.0200. We go to the table and we get a negative 2.05. So if I'm going to back up, excuse me, if I put these two tables side by side, they're kind of mirror images of each other. If I fold this paper right in half, they're kind of mirror images of each other. This one was increasing in z-scores. This one's decreasing in z-scores, and they're the same values other than the signs are exactly are opposites. All right. So I'm going to pick up the pace a little bit. So 0.9750, unless you got a question, would be 0.0250 over here. And that's what we're going to look for in the table. And if we do that, we get negative 1.96. And likewise for the 0.9500, now we end up with 0.0500. over on that left side, which is what we're looking for. And we get a negative 1.65. All right. And then if we had 0.9950, all right, that's, let's do that. No, that's not right. Let's do 0.9. How much am I going down by? It should be 92.50. Let's do this, 0.9. Yeah, let's do 0.9000. And that would leave 1 over here. And it'll be a negative 1.28. I don't know why I messed that one up. Okay. So real kind of quickly, I'm going to improvise here. So if I put these two together, and we could do this, here's 0 in the middle. And we're going to look at, let's do this. Let's see. Let's do that. Since we talked about, let's look at the middle 80%, right? Or 0.0800. Is that big enough for you to see? No, it's not real big, but we're going to come in there a little bit. All right. So if I've got 80% in the middle, I got 0.100 over here. I got 0.100 over here. If I put those two presentations that we just talked about together, all right, we are going to have this over here is going to be negative 1.28, and over here is going to be positive 1. I know this is a little 2a. Okay. That's putting together if we start looking at the middle 60%, 80%, or whatever the middle percentage that you want to look at. All right. So to kind of summarize, unless you've got some questions, make back up so you can maybe see both of these. Probably not big enough to see them both. No, that way.
You always subtract it from 1.
I'm sorry, say again?
You always subtract it from 1.
Yeah, because the z of alpha or z notation is always talking about the area to the right of wherever that vertical z line is. So you're always going to subtract the 1 to relate to the table. Now, if you were in class here, there's actually what's called a table. What you've been using here is kind of in your textbook keeps referring to as table 3. This doesn't say table 3 because I like this format better and I pulled this off the internet, but it's table 3 in appendix B of your book. Now, what you've done in your book, and if you happen to have your book at home, they have what's called a table 4. And what they did is they took these little either end of the standard normal curve and just made a table out of that because we're kind of looking again at those little extremes on the left and right side of table 4. And it is, like I said, it's table 4 in your textbook if you want to look at it, and it refers to that, I believe, in some of the literature in section 6.4. But the summary being is this z notation or z of alpha. Again, you know by now, statistics likes to give different names to the exact same things just to kind of confuse things and muddy the water a little bit, is the area to the right of the curve, and then you find the corresponding z-score. And you just gotta remember that subtle difference. At any time you see z with something in parentheses, it's a z notation, z of alpha, and it's not the z-score, it's giving you that area to the right of the curve. And that's what I want you to take away from that. And it has particular usefulness when we're talking about, when we're doing the if you remember that slide, we're doing that inferential statistics and talking about and analyzing a set of data on the far left, far right side of the curve. That's kind of, again, I know I'm being somewhat general, but I don't, just because of the way we're teaching this, I'm reluctant to get any deeper into the weeds than that and make it more confusing than what it already is. Not to insult your intelligence, but it just, when I can't get instant feedback with body language and show you stuff and redraw stuff and look at it from different angles, which is hard to do in this format. I just want you to have some basic concepts to take away from this so that, because all you guys, particularly you seniors, no matter what you major in, you're going to take probably 2 stats classes sometime in your 4 years of college. And I wanted to have a little bit of foundation and base that you're not starting from ground zero. And you got some stuff Kind of build on it. Questions or comments or anything else we can go over? We've got a couple minutes left. Anything I can clarify on what we just talked about over the last 40, 45 minutes? Let me do a couple of quick housekeeping chores. Let's see. Tomlin and Walden, you never showed up, correct? You're not out there in La La Land? All right. That being said, I'll try to work on grading the quizzes from Monday. It may be this weekend by the time I get to them. I'm still playing catch up. I hope everybody has a safe and healthy and happy Easter, even under the extenuating circumstances that we're operating under.
You too, sir.
I'll see you in about a week and a half. Okay. No homework, and just enjoy the Easter break with family, whoever's confined to your house along with yourself.
Thanks, Mr. Gaffney. Love you, sir. Thank you.
All right. Have a happy Easter and stay safe and healthy.
Yes, sir. You too.
All right. We'll
Sir, you too. Have a good one.
see you in about a week and a half. All righty. Bye.